Hi, class. So I'm doing this video to help you learn how to add fractions. So 9/42 plus 3/70, how do we add those together? So first of all, I like to rewrite this vertically going up and down, rather than horizontally. And that provides us just room to build equivalent fractions. Because one of the biggest things that we need to do and we need to remember when we are adding fractions is that our denominator has to be the same. And so I think I was teaching you guys earlier that sometimes to remember how to do something, try to remember just one word or one little phrase and of the steps of the process, and that can kind of trigger your memory into helping you remember the rest of the steps. So here we just remember we need to have a common denominator. And I'm going to go ahead and write this problem out vertically, and that gives me more space to build. We need to build equivalent fractions. A fraction equivalent to 9/42 and equivalent to 3/70 that have the same denominator. So here's my original 2, and I'm going to write my equivalent fractions there and add those ones instead of the original ones, because I can't add the original ones. So let's find the common denominator that will work. And this is a hard task. And at least I found it hard as a student, and I feel like I had to go over it and over and over again to remember this process. So the way we're going to find the least common denominator is we're going to prime factor both 70 and 42. So 42 is 7 times 6, and then 3 times 2. Okay, and 70 is 7 times 10, and then 10 is 2 times 5. Okay, so I prime factored both of those numbers. Prime factorization of 42 is the end of all those branches. So it's 70 times 2 times 3, and then 7 times 2 times 3, and then 70 is prime factorization is 7 times 2 times 5. Okay. Now the LCD has to contain all the factors of 42, all the prime factors of 42. And it also has to contain all the prime factors of 70. But they don't have to appear there at the same exact time. So here's a way to think about it. What you can do is look at the factors of 42 and look at the factors of 70, and then let's do a Venn diagram. A Venn diagram is where, like, the ones that they share in common, we're going to put in this overlap area. So these are the factors of 42, these are the factors of 70, and the ones that are common to both, we put in this overlap area. Okay, so the 7 and 2 are common to both. So I put the 7 and 2 in here. Okay, and then the 3 is only common to the 42, and the 5 is only common to the 42. And now I just multiply all those numbers together. That's my LCM, or LCD, or it's also the LCM, or the least common multiple of the denominators, or least common denominator. So it's the 3. I just list everything that the 7, the 2, and the 5. There's my LCM. So there's not too many steps to this process. I had to prime factor, I had to write my Venn diagram, and then I get the LCD. Done. So we actually multiply these together, and that's 5 times 2 is 10, and 3 times 7 is 21. So it's going to end up being 210 is our least common denominator here. However, you might find it a little easier to just leave the LCD in this prime factored format. Let me show you how it's going to save you a little bit of time. So if I just write this 3 times 7 times 2 times 5, that's common denominator. I notice that 42 times what equals that number? Well, 42 is 7 times 2 times 3. So the one that's missing here is the 5. So I need to multiply by 5 on both top and bottom. And I get 45 in the numerator. And the same thing with 70. I see 70 is the prime factorization is 7 times 2 times 5. So the one factor that's missing from 70 that is over here is the 3, right? Because they both have 7, 2, and 5. The prime factorization of 70 has 7, 2, and 5, and the prime factorization of our least common multiple has 7, 2, and 5, but the only one that's missing is 3. So I need to multiply the 70 by 3 to get this least common multiple denominator. So I multiply the numerator as well, and then I get 9 in the numerator. And then now I just have to add them together, and I get 45. Now I just add the numerators, 45 plus 9. So that's 54 over, and then now I'm going to actually multiply the 3 times the 7 times the 2 times the 5, which when you now recognize that is 210. However, even this is going to even be more valuable for us as well, because now we have the task of we need to be able to reduce this fraction, otherwise we're not going to get this problem correct. So I already have prime factorization of the denominator. I'm going to prime factor the 54, and I get 6 times 9, 3 times 3 times 2 times 3. So I'm going to rewrite that. 54 is actually 2 times 3 times 3 times 3 divided by 3 times 7 times 2 times 5. And you'll see any common prime factor to the numerator and denominator we can cancel. So these 3's can cancel, and anything else. The 275. Oh, and the 2's can cancel. So that leaves us with 9. I just multiply what's left. 3 times 3 is 9 over 35. And there we go. That's our completely simplified result. All right, and you'll notice we don't have to just sit here and check, oh, is there any number that goes into 3 to 9 and 35? We don't really have to check that because I already prime factored the numbers. Okay, and here's something interesting to kind of think about. If they don't have any common prime factors in the numerator, and when you prime factor an expression, and it has no common, the numerator and denominator have no common prime factors, there is no other number that will go into both numbers. Okay? Either those prime numbers or a combination of those prime numbers are going to go divide into both the numerator and denominator. But if they have no common prime factors, then no number is going to divide into both the numerator and denominator. So I don't have to sit here and think about, okay, well, does 3 go into 9 and 35? No, I don't have to think about it all, because the only numbers that divide into 9 are 3 and 3, and well, 9 itself, but that's just a combination of the primes of 3 times 3. So if those prime numbers don't go into 35, I'm done. There's no other numbers that can go, that they can both have in common. Okay? So I know it's reduced completely. That's a great way to reduce things completely. For the longest time as a student, all I knew how to reduce a fraction was let me just guess and check at numbers that I can divide into 9 and 35. And I would sit here and do, okay, well, does 2 go into 9, 5? No. Does 3 go into 9, 5? No. Does 4 go into 9, 5? And I would go through all the way through the numbers, just working my way like that. But when you do prime factorization, it makes it real easy. The only numbers that go into 9 are 3 and 3. So all we have to check is, does 3 and 3 go into 35? And none of them do. So, well, 3 is the same as 3. No, and so if 3 does not divide into one number, then 9 will not divide into that number, because there's just going to be twice as many, there's just going to be twice as many threes within a number that's divisible by 9. So if it's divisible by 9, it has to be divisible by 3. So we know that it's not, the prime factors of 9 do not go into 35. So therefore, this is reduced completely. All right. I hope you found that really helpful, and let me know if you want, I'll make another video. Bye.